We're back. All right, got me some drink of water, so I'm not going to be coughing anymore here. Like, what was that? What was that? Corona. Now, I feel fine. So here we have, I just picking right up where we left off. We need to get a mathematical solution for how fast and in what direction I am flying my plane with this crosswind. Remember rowing down the stream? We just simply added the numbers and said downstream. And if the downstream was written correctly, it would have been east. You could have said downstream or east. Downstream isn't always east. Downstream could be north, but it depends. So upstream was another answer we got. We're rowing at 0 degrees upstream. I mean, you're trying to move upstream. You're not. You're moving at 0 meters per second, not 0 degrees. So 0 meters per second when we turned around, trying to move upstream, I suppose. We were pointed that way anyways. We're just not going anywhere. So we say upstream at 0. Not very fun, except for me. I thought it was fun to watch. We mathematically have to solve for this red arrow, because that's the answer. That's the resultant. Okay, right here, we got that. Now we drew it correctly. Now we got to do the math. Math, well, this is a right triangle. North and east are at right angles to each other. So it's a right triangle. Right triangle math isn't too bad. Some of you out there do not like trigonometry. You do not like this stuff. You don't, but you've got to do it. You've got to try, man. You got to try. Because this stuff, this triangle stuff, carries through the semester. So you got to learn it, okay? Learn it. Don't fight it. Don't fight it. Do it. Here we go. First thing, I don't think too many people have a problem with that guy from Greece. What was his name? One of those philosophizers. Aristotle, Plato, Socrates. Remember I told you about them. Pythagoras was his name, not Pythagorean. Pythagorean theorem, we get that. You know that. A squared plus b squared equals c squared. Okay? Not hard. So we can figure out this side of the triangle by using Pythagorean theorem, and let's do it. A squared plus b squared equals c squared. So I want c, this is side c, so we'll take the square root of a squared and b squared. So this is 10,000. This is 900. So 10,000. 900. If we take the square root of that, we will get this side. All right. Hopefully you get an answer. It's going to be more than 200. It is the hypotenuse of the triangle, the longest side. So if you don't get more than 200, you know you're getting something wrong. The other thing is, too, it's not going to be like 500. I mean, look at that. It's a little bit longer. It's going to be much greater than 200. I don't know, 210, 220, something like that. 30. Let's find out. Let's see. So the square root of 10,900. Second function. Second function. Boom. 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 Did I say 200 and something? Don't listen to this guy, okay? Don't listen to him. Didn't have any coffee today. No coffee. It's cold out. I didn't have any coffee. No, I'm a mess. 104, not 200. I tell you, let me make sure that 104, 104.4, but we'll say 104. So where is my red marker? There we go. So C is 104 meters per second. Now, oh, that's it. We're done. We're finally done with that problem, man. You babbled for a long time. Finally, you're done. Move on. Are we? Are we? This is a vector problem. We're finding the velocity of the airplane here as a result of moving north in a crosswind. Now, we got the speed of that vector. That vector. 104 meters per second is the speed of that velocity. It's not the velocity. What do we need? What do we need? Barney. We need direction. That is correct, Barney. You need direction, and I am here to provide you with direction in your life. Okay? I'm here for you. So we also need direction of which way this plane is now going. Oh, well, that's north and that's east. It's northeast, right? We can just say 104 meters per second northeast in the northeast quadrant. That's good enough, right? And now, If I have a package delivered to Phoenix, Arizona, and you have an airplane, and I say, here, man, take my package and please bring it to Phoenix, Arizona. And you might say, where's Phoenix? I don't know geography. Southwest United States. Just get in your plane, fly Southwest. Not the aircraft, not the airline Southwest. Fly to the Southwest in your airplane. You'll run into Phoenix eventually, okay? Maybe you will. Probably you won't. Why? Because it's not specific enough. We need an exact angle that we are moving in the northeast quadrant. So, here is guideline numero 3. Guideline 3. I'm going to get this out of the way. Now, you remember that 104. All right, did you remember it? Good, because we're writing it right here. 104 meters per second. All right, guideline 3. Always find the angle, okay, I'll symbol angle, where the two tails meet. Find the angle where the two tails meet. Two tails, what are you talking about? Well, that's head to head. That's head to tail. That's tail to tail. You need to find this angle. Find the angle where the two tails meet. You always need that angle when doing a vector problem. When you have a triangle, whether it's a right triangle, which this is, or a non-right triangle, you stay tuned for that. Okay. So we need to find this angle. In math, you typically will call an unknown angle theta. Make the Greek letter theta. All right. So Greek letter theta. So we need to find theta. Now, sometimes I just like look at theta and I look at that and I see, what do I see? I see a Pokemon ball. That's right. You know you do. You see it too. Gotta catch them all. Gotta catch them all. Personally, I'd probably go with Rockingham Mall. If I'm going to catch a mall, I'll probably want to go with the Rockingham Mall. It's a mall joke. Catch them all. Hell, I gotta hold it. It's pretty heavy. All right. Sorry. Bad joke. There's my Pokemon ball. So find angle Pokemon ball. You need to find, I'm even going to put it in here. Find the angle the two tails meet. That's angle Pokemon ball. You want to write that down? Oh, yeah? Just did. Find that angle. You need that angle to state the direction correctly. So let's go ahead and solve for that angle. Here we go. Some of you, yeah, you know it's coming. SOHCAHTOA. SOHCAHTOA, if you stub your toe in the wall, what do you do to make it feel better? SOHCAHTOA. Oh, I'm on a roll today. Better than being on a bun. I'm on a roll. Whoa, stop. Okay. SOHCAHTOA, sine, cosine, tangent function. You're going to need those. Those don't go away. I know you said to yourself back in the day when you were sitting in your geometry class, when am I ever going to use this? This is so stupid. I'm not going to use this ever again. Right now. Right now is when you're using it again. If I were your geometry teacher, I would say in your physics class. Okay? So you need to use SOHCAHTOA. Sine, cosine, tangent. I memorized this. My geometry teacher back in the day said, oh, have a little catchphrase. Little catchphrases help you memorize. I mean, some people might just remember SOHCAHTOA, but I remembered it as some old horse caught another horse taking oats away. I know, it sounds stupid, right? But it worked. I remembered that. Some old horse caught another horse taking oats away. Sometimes a student memorizes this as some old hippie caught another hippie tripping on acid. Okay? No drug references, please. Not in my class. Not my watch. You need that. You need to solve for this angle. That's the angle. From this angle's reference point, this is next to me, my adjacent side. This 100 is my adjacent. Opposite is the 30. That's opposite. And right next to me on the right, well, that's adjacent as well. It is adjacent, but it's called the hypotenuse. How do you know? Longest side, opposite side, 90. Opposite the 90 degrees. Side opposite the 90. So that is my hypotenuse. Opposite hypotenuse, adjacent, hypotenuse, opposite angle, opposite and adjacent. So you might say to yourself, well, which function should I use? Now that I have all three sides, I can use any function I want. I mean, technically you might hear it said this way. Well, since these are the two known values, and this was calculated, and we did round this one. I rounded from 104.4 to 104. So it might be a little bit more accurate to use these two values that I know didn't have any rounding in them. But I mean, technically you can use any one you want. It's America, pick which function you feel like you're in the mood for, and then go for it if you have all three sides. Let's see here. Marcy, what are you thinking today? Sine, cosine, or tangent? You make the call. Let's go tangent, because we had those numbers to start with. All right, we don't have to, but okay. So we're going with tangent. The tangent of this angle is equal to opposite over the adjacent. So the tangent of angle Pokemon ball is equal to the opposite 30 over the adjacent 100. 30 divided by 100 is 0.3. Oh, so the angle's 0.3 degrees. No, that's the tangent of the angle. All right, get your TI-80 something or whichever works for you, scientific calculator. Your cell phones have scientific calculators on them, so you can use that. Figure out what is the inverse tangent of 0.3. You see, the tangent's 0.3. What we want is the angle. So what I would do on my TA something or another is I would say, okay, there's the tangent button, but I don't want the tangent. I have that. 0.3 is the tangent. So I would say second function, tangent, second function, tangent, because I want the inverse of the tangent. 0.3, enter. And it tells me 16.7 degrees. 16.7 degrees. So I will write an angle Pokemon ball is 16.7 degrees. Finally, we're done. We're all done. Well, kind of, pretty much. We're pretty much all done. How do we now state the final answer here for the direction and speed, therefore the velocity vector? Remember, it's velocity is a vector. What's the final way of stating the velocity vector of this aircraft? Okay, it would be 104. I'm actually going to go back and put the 0.4 in. Meters per second. Usually I want you to go one place after the decimal point, so do that. Get in the habit of doing that one place after the decimal point. Don't worry too much about significant digits. I said don't worry too much. I don't want you giving me a whole calculator answer. Take that calculator answer, just round it to one place after the decimal point, and that's usually good. It's 3 or 4 significant figures, which is typically how I set my problems up. Okay, what else? Comma. Now the angle. 16.7 degrees. But we have to say in what quadrant? North and east. So 16.7 degrees, oh, you say northeast, we're good? 16.7 degrees northeast? No. We have to say it like this. 16.7 degrees north, or actually east from north. East, because I'm here, so east from north. Well, why'd you say it east from north? Because this angle is being measured from north. This is north, the principal direction north. So when we put the angle in, we always put the principal direction that we measure from second. 16.7 degrees east away or east from north. Sometimes people like to say east away from north, and that kind of helps them remember, oh yeah, we're measuring away from the north. So east from or east away from the north. Now, remember back when oh, I can't remember who it was. Was it Billy? Maybe it was always Billy, right? Billy or Marcy picked that out. But yeah, Billy. I asked Billy, I said, what do you want to do with this arrow? Do you want to move it here or do you want to move it down here? It doesn't matter. We'll solve the problem. Same answer either way. And Billy said, well, put it up there. And I said, fine, great, good. What if Billy said, no, I want that vector added head and tail down here? What happens now? What would I do? get rid of this, clean this up a little bit. I would draw in my result, tail to tail, head to head, just like I did here, tail, tail, head to head. And look at that. We have a nice little parallelogram set up here because this line here is parallel to that line there. They're identical. Those two lines are identical. So whether or not we moved that 30 up top or on the bottom, I have an identical answer. This is identical to this. And if I do Pythagorean theorem, a squared plus 100, that was a 100 squared, equals my c squared, I would still get 104.4 for that side. Now, what would be different is you would find the angle where the two tails meet. Remember, that's guideline number 3. Find the angle where the two tails meet. And that angle would be this right here. That angle would be angle Pokemon ball. And you can tell, you know, that that is bigger than that. But I go ahead and I do the math on it. I would still use tangent. And I'd say the tangent of angle Pokemon ball is opposite over adjacent. And this is the opposite side. That's my adjacent side. So that's 100 over 30. Okay, so the tangent of Pokemon ball in this case is 100 over 30, which is 3.12 evil, 3.333. And if we go ahead and put that, now that would be the angle, the tangent of the angle, but not the angle. We need the angle, so once again we use second function tangent, 3.333, and I would get an angle of, you ready, 76.3 degrees, 76.3 degrees. Do you notice something? Do you see it? Are your eyes going, wow, and your brain going, oh, light bulb? (76.3) and 16.7, what do they equal? 90. Boom! 90. This would now be stated, however, 76.3, not east from north. Not east from north. This would be 76.3 north from east because we would have measured it from the principal direction east and we would measure from the east toward the north. So this would be 76.3 degrees north of east. Those aren't the same. Those are different answers. No, they're not. They're the same thing. They just look different, but they describe the exact same direction and magnitude. That line and that line you can see are the same, and the math bears it out. We'd still get the same length, and although it looks different than this angle, 16.7 and 72.3, they have the same direction associated with them. If you're going to travel directly northeast, if you went dead center, right down the middle of north and east, you know what that angle is. Halfway between 90 is 45. And if I said, I want you to travel 45 degrees north of east, 45 degrees north of east or north from east, that's it. If I said, I want you to travel 45 degrees east from north, 45 degrees east from north, same thing. So these are the same direction, even though they might not look the same. So you have a choice when solving a vector problem, which makes a triangle. You have a couple of choices how you can add the two vectors, and somebody else might get what looks like a different answer from you, but if they've done it right and you've done it right, it means the same thing. All right, that is how to solve math of a right triangle vector.